Kim's a very experienced both sort of teacher and author. He's authored many books on strategy dynamics. He's been very influential, winning awards as well along the lines, I believe. So he's here, he's going to talk about living business models. That was the intriguing title that we've had. So if we have a round of applause for Kim then, would you like to come and join us?
Thanks very much. So I'm going to talk to you about system dynamics this afternoon, and the real reason I'm here is to see whether there is some more contribution that system dynamics can make to your world. I'm not a systems engineer, although some of my best friends are. So just so I get a flavour of where to pitch this, let's use one of our own frameworks from system dynamics. Can I just ask, how many people in this audience have actively used a system dynamics model of any significance? Okay, so a few people have. How many of you have got a reasonably clear, excluding those, how many of you have got a reasonably clear idea of what system dynamics is, even if you haven't used it? Okay, and I guess the rest of you have heard the word and the phrase, but you don't really know what system dynamics is. Would that be about fair? Okay, all right. So first of all, why this phrase, living business models? Well, if you go to management in any organisation and say, I'm going to talk to you about system dynamics, they think you come from the IT department. And if you actually use the phrase system dynamics, they think that you're some kind of pointy-headed guy from the university who's got no touch with the real world. What they do understand, at least they think they do, is this phrase here, business models. And I put that word on the front to indicate that the models we're going to look at actually are working quantified simulations. And before I go any further, can I urge you to take a note of certainly that link there, sdl.re/SESD slides. The reason for that is that I can only really scratch the surface of what SE can do this afternoon, but there are loads of links to other resources in these slides. There's also a full article on what I'm going to talk about at that link there. SESD paper. It's rather longer than the short article I was able to submit for this afternoon. And to make this story more accessible, I've broken it up into 3 LinkedIn Pulse articles. The first one is at LIP SESD1. That will take you the link on to Article 2 and Article 3 in the series. So this is all with a view to making what I'm going to say accessible to more people. So, enterprise management needs simulation. The people who run our organisations, they need simulation. Why do they need it? Well, they need it to design the enterprise that they're going to launch, or they need it to design the plan for the initiative that they're going to run, or whatever it may be, and bench test that before they actually risk money and people, and sometimes people's careers. If people try to start a new enterprise and it goes belly up, that can take a lot of people down with it. I think that's just an unacceptable consequence of experimenting on the real world, which is what we often do in enterprise management. Then it allows you to continually manage the enterprise in the light of how things are actually progressing, to make sure it does work as it should, and then we can anticipate future events. But none of this is any news to you guys, right? Because we've been doing this with physical systems for decades. So why don't we do it with the enterprises that we run and the things that we do? So we can have an HR strategic plan, we can have a marketing strategic plan, we can do it for the entire organisation. And I mean an organisation, we're not limited here to business cases, it works just as well in public services and non-profit cases. Or for one-off, time-limited issues. They can be very small ones, like, oh, we've got a service quality problem right now, how are we going to fix this? Right up to very, very big ones, like, we are going to acquire another company and integrate it with ours. It's a time-limited episode. It's not continuing the management of the whole organisation. Now, there are 3 related dynamic modelling methods, but forgive me, those of you who know all this already. I'm going to just explain the relationship between them in very simple terms. But before I do, I'd just like to point out to you that the consultants and the analysts and the management accountants who currently try to do business modelling or claim to do business modelling, what do they use? They use spreadsheets. That's the tool of choice. Right? And the spreadsheet just isn't fit for purpose. I'm preaching to the choir here, aren't I? It's just not a suitable tool for this. They can't handle threshold effects very well. It's very difficult to implement intangibles such as the impact of reputation or quality factors. So I'll say it's just not fit for purpose. We should be using better tools in this era. So there are two other approaches to quantified simulation modelling that are related to system dynamics. The first is discrete event simulation, which has been used for many, many decades to simulate how things move through a process, through a supply chain, through a manufacturing process, and so on. I guess everybody in this room knows all about that kind of simulation. And that's got very sophisticated, as we saw in a couple of the presentations this morning. Then there's agent-based modelling, which it adds to discrete event modelling by putting intelligence into the entities. So the entities have behaviour, they do things of their own volition. They don't just kind of sit there and get pushed around through a supply chain, for example. And they are both very powerful tools for entity-level time detail modelling. So I am in no way pitching SD system dynamics. I can say SD occasionally, but system dynamics. I am in no way pitching SD against those tools. They are very powerful. They have very strong uses. System dynamics, in contrast, does not concern itself with individual entities. Well, you can kind of force it to if you really want to. Rather, it concerns itself with what's happening to populations of things. So, groups of staff, numbers of products, quantities of debtors in your accounts, for example. Now, that has some big advantages. That is, first of all, these models can be very compact and very quick to build. They can handle all types of system elements, all related to each other in the same model. So we can deal with cash and people and physical items and intangible factors all in the same model and all related to each other. But that, of course, comes at a price. The price is that you lose anything about what's going on to individuals. So service quality may be fine on average for the whole population of customers who experience that service. But that doesn't tell you that one customer is having absolutely awful time. Right? We lose that in the system dynamics model. And there's a paper there which summarises the relationship between them. So let me just give you an example, a very trivial example. It just brings out the elements of a system dynamics model. So the elements are, we have these things called stocks. There are things in the real world that are called asset stocks. They accumulate over time. They just are fundamental to how the real world works. And they are added to by things that arrive, and they are depleted by things that leave. So this simple model, we've got two scenarios here. We've got a green scenario and a blue scenario. We want to have about 30 staff, but in the blue scenario, we react too late to the staff loss rate here, and even then, all we do is replace the staff that are leaving, so we get down to 20 and stay there. In the green scenario, we react earlier and we rebuild the staff. So you can try this yourself. Just go to that link. There's nothing to install, nothing to buy. Just go there to run in your browser. One of the difficulties we face in system dynamics is that people think it is a technical and complicated, difficult thing. Well, actually, if you just think of each item here as a column in a spreadsheet, with the name in the top cell and all the period values running down the cells, and the arrows are simply cell references, and inside each of these there is a formula, and there's a formula, total staff hours per week equals staff multiplied by hours per week person. It's not this. It's not that kind of formula. It's kind of English language or French language if you want. Well, the other confusion is that many people I speak to and talk about, we do business models. They immediately think we're talking about process modelling. it's not the same thing at all. There's a relationship between them, and just to illustrate the difference, this is a very, very simplified process diagram of hiring staff. So we place a job advert, screen applications, issue offers, receive acceptances, and if we haven't got enough people, we do it all again, and then we stop hiring when we have got enough people. So in this diagram, these are activities that are done to the things in the system, the things being the job applications. So the items in the diagram are mostly verbs. There are occasionally some nouns, but they're mostly verbs. It's things that are done to, or things that happen to elements. In contrast, this is a system dynamics model of exactly the same thing, but in this, every item here is the thing itself. And the objects are first of all, they're quantified, and secondly, they are nouns, they are not verbs. It is applications for review, candidates considering offer. They're actually nouns, not verbs. If you want to try this one for yourself, you can change the fraction of applications you accept, you can change the fraction of offers that are accepted, you can change the total hiring that you're trying to achieve in this simple model. The relationship is that in many, many cases, the verbs in the process diagram are actually located at these things that are called the flow rates. So place the job advert triggers that flow rate to happen. Right? Offers sent per week, well that's issued job offers. Right? So there's a relationship between them, but they are different. Let's actually start, kind of amplify this, and now move on and try and do something a bit more complicated. And the scenario here is that we've got a company that is selling products, industrial products to customers, and it's got a new service product that it wants to launch. And to do this, first of all, it's got to develop the new service, and then it's got to market and sell it. Okay? So what we have is we have a stock of tasks to be done, and it starts at 40, and when it hits 0, all the tasks have been done, the new product has been developed. Each task takes some number of person hours to complete. So task complete per week is how many staff we've got divided by how many person hours it takes to complete the task. It's just simple arithmetic in all these things. There's no kind of fancy maths or anything in that. Slight complication is that staff are being lost and the people we hire are not trained. So we actually have to change the hiring rate of trainees, and after a training period, then they become available to actually do the work. So in that model, you can try this. There are instructions in the model how to run it. We set two tasks. One is just run it as it is and change the hiring rate in order to complete the task in 20 weeks, but at minimum cumulative cost. So we're tracking the cost of all the people that we've got employed here, including trainees who cost us money but don't contribute to getting the work done. Or see if you can finish it in 15 weeks, and how many people do you have to take on, and what's that going to cost you? Second task you might try is, well, let's do some process improvements here. So you can just manually change this number of person hours per task from 500 to 400 or 350 or whatever you think it might be realistic. Or you could reduce the training time. Maybe it only takes 2 weeks to train people instead of 3 if you improve your training process. And then repeat the challenge. So can you hit the project completion deadline at minimum cost with these process improvements, and what does that do to the cost of getting it done? So now let's make this project part of this whole business initiative. So sorry if this is a bit scary, but everything is exactly the same as I've said before. Every item on here is just like a column in a spreadsheet, and all the relationships are just cell references. That's all it is. What do we got here? 30 items? Something like that? Anyone scared of a 30-item spreadsheet? Those accountants and consultants and analysts, they're certainly not frightened by 30-item spreadsheets, so they shouldn't be frightened by this. That's the bit we just did. So that's developing the new service. When the new service is complete, We deploy sales staff. This is take on sales staff here. And what those sales staff do is they start pulling potential clients for the new service out of this stock here and into this stock there. So this is the clients taking the new service. When they're in that state, they've got the new service, we now have to have service staff to support those clients. And if you haven't got enough service staff, those clients get poor service and they get annoyed and they leave. Okay? So we've got to make sure that we take on enough service staff and that they go through a training process as well. Now, what are we trying to achieve here? Well, we're trying to make money out of this, right? So what happens is that these clients pay for the service and generate revenue for us, and these staff cost us money, driving our costs, and you take your costs away from your revenue, and that gives you your profit, and this is the cumulative cash position. So this is, we're spending loads of money on people here before we get to the point where we start making money from the new service. And this is another model you can just go and play yourself. The pink items are the key decision points here. Hiring trainees to do the work, hiring service staff over here, and setting sales staff to sell the service to clients. Okay, so let's take a success case of actually using this in the real world. This is a company called Open. Has anyone heard of it? No? Anyone had a kitchen improvement project or a new loft extension or a new garage put on their house, anything of that kind? Yeah? Not easy, is it? It really isn't easy. It's a complicated thing. We don't do it very often. We are not, well, you guys probably are, but most of us are not skilled project managers. So this service actually helps householders do this. So my friend Rod, who launched this business, launched it in February 2015. First thing he did was he built a system dynamics model of how the business should work, how he thought it was going to work. He didn't employ anybody at this point. It was literally in his study at home. He built a working model of how he thought it would work. How many people do I have to take on? Of what kind? How many people might put inquiries on our website? How many of those might turn into potential projects? How many of those would turn into actual projects? Now, how many contractors do I need in order to actually provide these home improvement projects? So how many kitchen fitter companies do I need? How many loft extension companies do I need in the system? Having done that, and actually started with his friend actually hiring some people, actually raising some money, actually doing some web marketing to promote the service, he then started putting weekly data into the model. Every week he put in how many web inquiries have we had, how many of those have turned into project inquiries, how many of those have turned into live projects, how many new contractors have we taken on, how many contractors have we lost. How many of the new inquiries did we get because people who had had successful projects completed met their friends at the school gate and said, hey, this is a really good service, why don't you? I know you're having a kitchen extension, but a kitchen improvement done, why don't you ask these guys to run it for you? And what he then did is he shared this model with investors. The investors were the venture capital arm of Aviva, the insurance company. And Rod was able to raise £3 million to fund the development of his business. And periodically he would share the model results with Aviva, saying, this is how it should have gone, this is how it is going up to this point in time, and this is how I now think it's going to work. So the future is constantly adjusting in the light of what's actually happening. And the model is now used for weekly operating decisions. So there's a stand-up meeting every Friday, head of marketing, head of staffing, head of contractor recruitment, head of finance, and Rod stand around. They look at what the model is telling them about how the business is going, compared with how it should have been going. They say, oh, hold on. If those inquiries turn into projects at this rate, we're going to have an overload of projects in 10 weeks' time. So you, who's responsible for contractor management, we need you to quickly get out there and find us another 5 kitchen improvement contractors, because we expect to have that amount of work in 10 weeks' time. You can hear Rod talk about how he did all that, and how he's used the model in his business at that link there. And the stop press news on this is that in June, John Lewis acquired the business for an undisclosed number of millions of pounds. And of course they acquired the model and Rod along with it. So that's an example of a new venture application of this approach. Now, I know a lot of you will be much more familiar with modelling physical things, and we can model physical things as well, but bear in mind, again, we're modelling populations of things, we're not modelling what's happening to individual entities moving through the system. So this is a supply chain model. It's a very simple one. We've got orders that we have to deliver to customers, and those order numbers change, and we've got to decide how many we order from our supplier, and there's going to be a delivery delay. This is one of the classics in our field. It is astonishingly complicated in its behaviour, and figuring out policy to optimise inventory levels whilst achieving customer orders with no failures is a lot more complicated than it looks. It features in John Sturman's book on business dynamics, the leading book in the field. Asset ageing, this is another issue in many organisations. We have an asset pipeline concept where assets age, and the rate at which they deteriorate in performance, giving rise to unreliability stuff, depends on how much you spend on maintenance, on how much you spend on refurbishment, and how often you replace clap-out entities. So that's another example of a physical model. And I said earlier on that one of the big advantages of SE models is that they can encompass multiple aspects of the same situation. We can combine modelling of the things, the projects, the people, the money, environmental impacts, and so on. And this is an example of one such application. It concerns a big engineering project in the Netherlands to rejuvenate a essentially almost dead lake that had been dammed off from the sea. So there's a big engineering project to open up water flow between the sea and the lake. And that project looks at the environmental dynamics, it looks at the dynamics of the project itself to actually get the thing built, it looks at the dynamics of all the hiring and other things that have to happen to make the project possible, and it looks at the dynamics of all the finances. So, is this a thing then? This is the question I'd like to leave you with, and I very much welcome any thoughts or discussions over drinks or dinner later this evening, where we're not only doing model-based systems engineering, we're now doing simulation-based systems engineering. We simulate everything that we can. Why? Because it's now practical to simulate any episode, any project, any initiative, any organisation. And quite to my surprise, I discovered that the government thinks we should do this as well. Because there's this thing called the Blackett Review of what they call computational modelling. They talk about modern system dynamics, but they're certainly talking about simulation as being a thing we should be doing, kind of any significant, risky, costly thing that we're thinking of doing. So, if you'd like to know more, here's a few resources you might like to look at. Now, this first one, the way in which system dynamics models have traditionally been built is it's got very close analogies to the waterfall approach to IS development, where you start by scoping everything out, asking everybody what they want, asking everybody how they think everything should work, and then you throw it over the wall to somebody to actually turn it into model code. And that takes too long, costs too much, may very well end up with a model that doesn't work, and leaves us with a bad reputation. And I think there is an alternative, and there's a paper at that link there, sdl.re, Agile SD, where I make the case that actually SD models should be nothing like as difficult to do as we've made it out to be. So I hope that's left a few minutes for questions and discussion.
Well, thanks very much, Kim.
I really am in listening mode here, so I really want to hear.
Okay, so Richard, observing the protocol, off you go.
One of the applications I'm immediately started thinking of is, could we model our processes for producing products and set the process metrics, find out what the best process metrics would be? We always have this problem of processes are a system, but they're individually set up.
The way processes feature in a system dynamics model is that the process will determine how long something takes to happen and how much work has to be done to make it happen. So you can simulate what the impact on the dynamic performance would be if you were to change or improve those processes. And there's a particular thing that I've done for the strategy field, which is for a capability to be strong, capability to do anything, you need enough of the people to do it. Those people need to have enough skill. They need the information necessary to do it, and they need efficient and effective processes to make it happen. You put those four things together, you've got some capability. So we can model what would happen if you change the time a particular process takes. Yeah, you can certainly do that.
So like a set of goals for process improvement.
Yeah, absolutely.
Which actually would produce real benefit as opposed to just be,
yes,
it looks better.
Yes, but and you would also know whether that was going to have the desired impact, depending on whether the staff have got enough skills and if there's enough of necessary information available. Yeah.
Brilliant. Michael, so who you are?
Hi, I'm Michael Gibson from INCOSE. I had a sort of couple of questions which are sort of part of the same question, probably.
Right.
So I was wondering about the universality of the modelling concept within system dynamics with this.
Right, so two questions. First one is, are the elements of systematic model universal? Well, yes, they are, because the world consists of asset stocks that are accumulated, whether it's stocks of fish in the sea, stocks of government debt, stocks of carbon dioxide in the atmosphere, stocks of natural resources under the ground. Those stocks flow, they get added to or they get depleted. That's just a universal thing about how the real world works, so you can apply that to kind of any field. Everything else in the model is just other stuff. It's other relationships to other things. But my golden rule when I'm teaching this to other people is that everything you put in the model should be an observable real world thing, which you can actually go out and see and measure, even intangibles. Like we can actually go and measure staff motivation levels. What the HR field has struggled with is connecting that up to what that then does to staff attrition, staff productivity, and therefore enterprise performance. So yes, the fundamental components are universal. The other thing to say is that there are plenty of very generic templates. One of the examples I use, because everyone understands it, is a restaurant. So the restaurant consists of customers who use it, a menu, seats, and staff. Right? Every restaurant in the world, every table service restaurant in the world has those things. Doesn't matter whether you're talking about a fine dining thing that people spend hundreds of pounds on, or a little neighbourhood diner where they go out and they spend 15 quid. Right? Every restaurant in the world conforms to that model. The numbers are all different, the strengths of the relationships are all different, but every model, every restaurant. And the same would be true of every law firm, of every oil company, whatever. They all conform to standard models. Your other question was the digital twin thing. I would argue that what Rod has in his business is a high-level digital twin, but it's a very high-level digital twin. It's got about 60 items, I suppose, in the model. It's enough to capture it. The difference with the true digital twin, though, is that you're capturing every event and every entity's moving through the system. I have friends at a company called Sinudyne, Sinudyne, The relationship is that an SD model would be a high aggregate level. The agent-based model is tracking every transaction and every instant.
So building systems dynamics model is quite easy. Instrumenting it with real-world data is hard. One of the barriers to adoption.
So there are two bits to that question. If you look at the Agile SD paper, you'll see that I am proposing a process for building models, which is very incremental and stepwise, and you validate the model at every step. Every single item you add, you put the data in that you've got, and you check that the model is doing what the real world is doing. Now, in principle, that's really not so difficult to do, because you're only adding 1, 2, 3 items at a time to a model that is already working. Okay, it is already replicating the real world. It's just only replicating this bit of it at the moment. So now I add this bit on, and I check that that works, and now I put this bit on and check that that works. And I've done that on a number of projects now, and it seems to work. The second part of the issue that you asked about is real-world data. And we like to think that we're in this world of big data these days, where we've got all the data that we need on everything. Well, no, we don't, because we haven't bothered to measure it. Case in point, I had a senior HR guy in a global medical devices company said to me, we're really worried about staff turnover. It varies hugely between Japan, Germany, United States, whatever. We don't understand why. I said, well, okay, so let's have a think about what's going on here. And what can you tell me about your staff? I said, we know everything about our staff. We know how many we've got. We actually do know how many leave and how many we hire. Not every company does know that, by the way. And we've got all the staff satisfaction surveys on 20 metrics. We've asked them 20 questions about how they feel about working for us. But that's very good. So your concern is about the turnover rate. Yeah. So why do people leave? Well, we never asked them that. We never ask people why they actually leave. We think it's because our competitors pay more, or because they're overworked, or they don't get enough promotion prospects. But no one bothered ever to ask people who leave why they leave. So there's loads of that around every organisation. We simply aren't asking about important data.
You're Angela.
Yeah.
He's 5 minutes in the bar, just said. Can we show our appreciation for